All right. So the title, inverse trigonometric functions, what are those? That sounds awesome. And then, so what's the first question asking? So question one, what are we looking for? All right, so sine of what angle equals -1/2? We're looking for theta. All right, so let me ask this. How many answers are there to that question? One, okay. How do you figure out sine of what angle is -1/2? Before you get to that, we don't need to do that to answer the question. We can answer the question just from this. There you go. All right, but where? We mean it's more than just 30, 60, 90 triangle. You're right, there's a 30, 60, 90 triangle involved. So now you're getting warm. We know it's an angle. It's something to do with 30, 60, 90 because you got the -1/2 ratio. So you're still kind of warm. What else? I mean, how are we going to find the answer? Right? I mean, if I just draw a 30, 60, 90, that's not enough. Yeah, that's not enough here. Because I can see that one of those angles, sine of the angle is 1/2, but I need -1/2. Graph it where? You don't need a circle. You don't need to use.
Flip it over the x-axis?
What's that? Well, guys, it should be a process. I gave you a recipe for this stuff. Just you got to use the recipe a little differently. First question you should ask yourself, which quadrants is sine negative? You should have this, the thing that I said is the most helpful. Third and fourth quadrants. All right. So now you know it has to be an angle that's either in the third quadrant or the fourth quadrant. All right. So let's go to the third quadrant. So it has to be an angle that's in the third quadrant. I'll make my triangle. All right. Now let's get to your 30, 60, 90. If we're saying that sine of an angle is -1/2, then let's label each side. What does this side have to be? Not 1. -1. What's the hypotenuse? 2. What's the adjacent if you want to put it? What's the reference angle? No. Reference. Just one step at a time. What's the reference angle? The small angle. What's the small angle right there? It's on here. The answer's there. 30. So now what's the big angle? All right, that's one answer. Goodness, I'm exhausted. There's one answer. Okay. Where else is sine negative? From this fourth quadrant. Do the same thing. Draw the angle. Drop the perpendicular. All right, we'll come back to this. You should already know what the reference angle's got to be. If opposite's -1 and hypotenuse is 2, then what's the reference angle? 30. What's the big angle? All right, there's two answers. So it's sine of 210 and sine of 330 should be -1/2. All right, what about this angle? -150. If -150 lands there, has the reference angle of 30, it's going to be this exact same triangle. So should -150 work also? So what -150 is what with 210? Coterminal. So we could just say 210 plus or minus 360n. How many angles is that? So if I just keep going coterminal this way, this way, this way, this way. Yes, say it louder.
Oh, infinitely.
Infinitely many. Answers to that one? And then 330, how do you do coterminal with 330? Plus or minus 360 in. So the answer to the question is, there's my answer. How many answers are there? Infinitely many. Now this is one way to work the problem. There's two ways. This is the way I prefer. This is the way I will teach you when we get into solving trigonometric equations, which we'll do later. There's another way to have worked the problem. I don't think it's as easy to get the answer, but it's easy to visualize. Anybody know what's the other way? What have we been studying? What's the last two sections? What have we been studying? The graphs, the waves. You graph this and graph this. You're just looking for the intersection. Where does the wave sine of theta intersect with -1/2? So if we look at sine of theta, it's a wave that goes forever. Right? The peak is at 1, the valley is at -1. -1/2 is a horizontal line that goes like this. So notice, this answer here should be the same as your 210, but you don't do 210 degrees. It would have to be radians. For plus 1 million, minus 1 million, do you know the radian equivalent of 210? 7 pi over 6. How did I get that? Because 7 times 30 degrees is 210. 30 degrees and pi over 6 are the same. 7 times 30 is 210. 30 is pi over 6. A very easy way to convert. All right, there's your 210. Guess what angle this is right here? Look, this is 2 pi right here, right? 360. So what do you think that answer is? That's your 330 right there. There's your second one. See, there's your 210. That answer there, that's your 330, but we don't use degrees. We got to use radians when we do a graph. Anybody know what 330 degrees is in radians? Very good. 11 pi over 6 plus 1 million minus 1 million. So there's those two answers. And then what happens? How far is it from here to this next answer? See, on this part, see, it's on the downslope. How far is it from this answer to this answer? Horizontally, how far? 2 pi. How do you know that? Because sine is 2 pi periodic. It repeats every 2 pi. So there you go. 7 pi over 6, which is the same as 210, plus or minus 2 pi, which is plus or minus 360n. Same answer. But you can't tell from the graph where that crosses. I'm just showing you how to visualize it. All right, here's your 330s on the upslope, see? So the next one is there. How far is it between these two intersections? 2 pi. There's your, does it just keep repeating? I think it's easier to solve with triangles because it's easier to get the correct answer. There you can't really, there's no numbers. But the answer to the question is, there's a lot of thetas. And they're all coterminal with 210 and 330. That's it. Okay? That is the answer. Now, we're going to get the calculator to give us this answer. Here's what I want you to do. Make sure you're in degree mode. So go to mode, do degrees, and do inverse sine of -1/2. Now, you might know what question it's asking.
What's the angle?
Yes, it's exactly right. Sine of what angle is -1/2? It's almost the same as this, but it's a little different. There is only one answer to this question. It is what the calculator gives you. What does the calculator tell you? -30, which is coterminal with this here. See, if you've got 330, if you subtract 360, when you do coterminal, you get -30. That's this one here. So the answer is -30, and that's it. And it's actually negative pi over 6. We actually put the answer in radians. But that is the answer. Only one answer. So here, there are infinitely many. And here, there's only one answer. And and the answer was this. Negative 30, negative 5/6. Okay, so what did I help to show you that there's infinitely many answers to this question is that sine is a wave that goes forever, negative 1/2 is a horizontal line that goes forever, and thus there's infinitely many intersections. So now, our focus today is on the inverse trigonometric function, which is this is actually a function. What we're going to do is we're going to develop this function, and I'm going to show you why there's only one answer. Okay, this function actually has a graph. Okay, so that's where we're going to go. Right now, I need to change gears to get our focus here. All right. So, question. Do you remember what did we do? What did we talk about with if we're going to use if we're going to talk about inverse trig function, then we need to think back to inverse functions. Do you remember what were some important things about inverse functions? What were the characteristics? Y equals x, so they're symmetric about y equals to x. Very good. So if f of x is x cubed, its inverse is the mirror about y equals to x. So I'll draw the inverse again. See if you can remember what this is. There's the inverse, and we denote it f inverse of x. Do you remember what the inverse is? Like the equation? Not 1 over. Cube root of x. Cube root of x is the inverse. Okay? But what happens with x's and y's? They switch. So for instance, if this here was a point 2, 8, then what's the mirror point over here? A2. Right. If 327 is a point, what's the mirror point? I'm running out of room. 27, 3. So remember that the x's and y's switch. All right, what was another criteria if we're talking about inverse functions? Do you remember what's the criteria on the original function? For instance, this here, x squared, does it have an inverse function? Why not? Let me get Haley. Well, you were doing so good and then you just panicked. You looked like you were going to give me a great answer, and then these bozos were trying to answer on top of you. Try again. Take a deep breath. You know the answer. Yeah, so what happens is this. You're talking about, what test do we call this? Horizontal line test. So look, this has the point negative 2, 4, and 2, 4. Right? So what happens when you switch those? They become what points? What anybody help her out? What points do they become? You guys just said, you just showed me, if 327 is a point on one, what's the other point? 27, 3. What did you do with x and y? You switched them. So if 2, 4 is a point on one graph, what's the point on the inverse? 4, 2. So let's just say it's here. This. All right, 4, 2. What's this point going to be? 4, negative 2. That's going to be on the inverse, which is this graph here. What do you notice? Not a function. Why is it not a function? Because this function is not what? Has a name. 1-to-1. It is not 1-to-1. Since it is not 1-to-1, its inverse is not a function. Okay? Well, I'm doing all this because we're getting ready to do this for trig functions. So, How do we make it 1 to 1? All right, what's a restriction we could put on x squared? We could say the graph of x squared only for x what? Greater than or equal to 0. That's typically what we did. We cut it in half. Now, is it 1 to 1? Just this one? Yes. Therefore, you don't have this part here. And now, your function and the inverse, and what's this function? Anyone? Root of x. Are in their inverses and their functions, okay? So a couple of things, we'll go over some things we remember. It has to be 1 to 1 to have a function, to have an inverse function, sorry, to have an inverse function. And all x's and y's switch. Okay, all right, got it? Okay, now we're going to get started. I didn't start the lesson. So what are we going to find? We are going to find this function, the inverse of sine, this one. Okay. That's the function we're going to find. All right. This is called, and it does what you said. I like how you answered it. That in there is a ratio, so this means find the angle. So the output is always an angle. The input is a ratio. Okay. So what do we need to start with? If we want to find the inverse of sine, what should we start with? The graph of sine. Good. Plus 500 minus 5. Excellent. All right. I'm going to do what you told me, and we'll see if we need to make an adjustment. All right, there's sine. Hill, valley, hill, valley. Haley, do you see any issues with the graph of sine in terms of finding an inverse function? I'll give you a hint. It has the same issue that x squared had. What is the issue? It's not 1 to 1. Oh my gosh, it's not 1 to 1. First of all, it's a wave that goes forever. So since it's a wave that goes forever like this, the inverse is going to be a wave like this. See? It's going to be a wave like this that goes forever. Well, that won't be a function. So we need to keep it, we need to make it 1 to 1. Let me put these half pies in here. Okay. All right. So, what part do we keep? That's the $60 million question. We got to chop it. We got to restrict the domain, like you said, Spencer. All right. If I keep one cycle, does that fix the problem? Why not? Not 1 to 1. Fails the horizontal line test. One cycle won't work. All right, x is greater than 0. No. Look, if I go anything past 5 or 2, what starts to happen? Okay, I'm waiting, please.
Okay.
Thank you.
So it's greater than negative pi over 2, but less than pi over 2.
That's what we're going to keep. Everybody looked at what she said. Let's see if that works. Is that the biggest section that's 1 to 1? The answer is yes. That's it. That's the system. Are you sure? Yes.
Wait, so 1 to 1 means,
Means that if you draw a horizontal line, it can only cross once.
okay.
Because look, if I draw a horizontal line, because here's what's going to happen. If we did what if we kept all of this, right? Then when I go to flip it, it's gonna go kind of like this here. Something like that, and it won't be a function. See, when I flip, okay. So now here's the easiest way. So right now, what we are doing is to get this function, we're going to take sine from negative pi over 2 to pi over 2, and that's the what? What do you call that for this graph? What would you call negative pi over 2 to pi over 2? Well, it's not a cycle because there's more to it. Like this does not keep repeating, right? A cycle's this. Don't think in terms of trig, just think in terms of graphs. Negative pi over 2 to pi over 2 is the what for this picture? Starts with a D.
Domain.
Domain. It's the domain, because I want to show you what's going to happen. That's the domain, all right? What's the range? Yeah, and let me make it brackets, right? Because we're going to include those points. Negative pi over 2 to pi over 2, negative 1 to 1. What are the three main points that you see on this picture? What are the three main points that you see? We're going to write them out. Negative pi over 2, negative 1, what else? 0, 0, what else? All right, here's why I'm writing all that out, because right below this, we're going to do the graph of inverse sine of x. Now I'm going to know the domain, I'm going to know the range, and I'm going to know 3 points. How am I going to get all of that from this? Switch it, right? So what should the domain be? If the domain of sine is negative pi over 2 to pi over 2 and negative 1 to 1 on range, what's going to happen with domain and range if you switch x's and y's? What should the domain be? Negative 1 to 1. Because they're y's. Y's now become your x's. See? Now what's your range going to be? Negative pi. Look, guys, so let's try again. Look what happens. Look over here. What happens when I go from one graph to the other? Just say it. If you say it, you'll get it. The x's and y's what? So I'm going to switch up. Let's do the points first. So what should this point become? Let's do the points, and then the domain and range will be easier. Forget about domain and range right now. Let's just do the points. I know you know the points. Don't worry about domain and range. We'll come back to it. Look, what's this point going to be on our new graph, on the inverse? What should this point become? There you go. Negative 1, negative pi over 2. What's this point? 0, 0. What's this point? Because all you did was switch x's and y's. All right, so now I'm going to plot that. Negative 1, negative pi over 2. Now in terms of scale, negative pi over 2 is further than negative 1. It's 1.5, about 1.57. So in terms of scale, it should be a little bit farther from the origin than negative 1. Then here's your 0, 0. And then what's the next one? 1 pi over 2. There's that. Now I look at this one, this bends like this. So I've got to draw the inverse. So my inverse is going to be about the y equals x. So my bend, I'm going to make it different. I'm going to make it like this. And now you can do domain and range from the picture. And you can get the domain. Domain is what? Negative 1 to 1. What's range? Now you're going to save this. Just save it. Okay. So it took us some time, but that is the graph of inverse sine of x. Now I want you to see why there's only one answer. Remember the first question I posed today. What was the difference in, what did we have? We had one question, and the other question was inverse sine of negative 1/2. And I said there's only one answer. When you went and typed it in on your calculator, you got negative 30 degrees, but I told you the answer is negative pi over 6. So let's look at why that is. Because your graph is this. This is your function, okay? That's what we just grabbed. And x is your input. So all of the inputs, notice, are numbers between -1 to 1. Those are your x's, because our input has to be a ratio. Unless you were on the unit circle where you could use -1, 1, or 0. And so look at what the question's doing. It's just giving us, when x is -1/2, it's giving us the y. So look, it has to be a y value between 0 and -2. And see, your answer, we know, is an angle. Now, you can't visualize that that's -6, but how we get that later, I will show you. But that's why there's only one answer to this. It's just this point. When x is -1/2, what's the y? That's all that it's doing. It's telling us the point on this. Now, you can graph this on your calculator. Go back to being in radians. So go to mode. Go to radians. And just go to y1 and graph. You should have the button, inverse sine of x. And you should get the picture. All right, what we do with this, we'll get to that. We just need to get these graphs for now. All right, it's going to be hard to remember what it looks like. So what I would suggest is you label it how we've done. Give the domain, give the range, give the 3 main points, and then there's your picture. And then we'll come back to this. All right, I got to put this on the side burner for now. Because don't worry, we're not doing 6. We're only doing 3 inverse functions. Inverse of sine, inverse of cosine, inverse of tangent. Now, as you go through, now it becomes an easier process, because now we've already gone through it one time. But notice, what did I have to spend a lot of time on? This is where I can tell that this setup is not the best in terms of what you're retaining. He did pretty good with my questions, but what did I have to spend a lot of time on? Review. Because I don't think you retain as well in this, with what we're doing. Because there's no rigor on what you're studying. What do I mean there's no rigor? You can sit at home, eat your bonbons, you got 2 hours or 240 minutes to do a test. I never had that. I had to sit there and do a test in like 40 minutes fast when we were kids. So what I'm saying is, I don't think that you're pushed as hard, thus therefore I don't think you're remembering as much as you should. Because you can just use your notes to get by with everything. You won't remember it that way. Rigor helps you. Same as an athlete. If all you do is you lift the minimum weight and you run the slowest time, you're never going to get any faster. You go through the workout, but you won't improve. I'm not criticizing you. It's not your fault. I'm just telling you, in the system we're in, I worry about how much you retain. So there's the review. So now we've had a good review. If that's on the video, so for those of you at home too, you can mark those words down. Since I do help with courses at NTSU, I get in on some of their faculty meetings, and that's their concern that they're seeing is that students are coming into like the next level. If you're in Cal 1 and now you're going to Cal 2, they see that there's a drop off in terms of the preparation. So something for you to be aware of. And I got to try to help you with it too. Maybe we got to do some more review stuff, okay? So it's not all your fault. I'm not saying it's your fault. I'm saying it's the system. Okay, what's next? This graph. So we're going to come up with this graph. What do we need? Cosine. Very good. Now, if you remember, cosine is what about the y-axis? Symmetric. Therefore, we can't go left and right of the y-axis. I'm just going to do a rough sketch real quick, right? So if we go -2 pi to 2 pi, if you remember, it looks like this. So here's the problem. If I go left and right of the y-axis, it's always going to fail what? Horizontal line test. That's exactly right, okay? So you can't do left of the y and right of the y. So -pi, so your suggestion earlier, it wouldn't work on this one because we got a different picture. So let's make it, how do we make it 1 to 1? So let me label some points here. So this is the point 0, 1. This right here is the point pi over 2, 0. This right here is the point pi negative 1. This right here is the point 3 pi over 2, 0. And then we're back to 2 pi 1. So you got all the points. How far can we go to the right and have a 1 to 1? What's the biggest 1 to 1 section we can get? Let's have someone else see if they can pick it out this time. Where's that? 0 to pi. The biggest section. 0 to pi. So let's write this out. So we're gonna cut it to here, right? That's not an asymptote. I'm just like making a slice right there, okay? So the domain that Spencer selected is 0 to pi. What's the range, Spencer? Still negative 1 to 1, right? Yeah, negative 1 to 1. And then what else? What are the three main points? So we got 0, 1, pi over 2, 0, and pi negative 1. Why am I collecting all this? Why am I putting this here? It's like I'm taking notes. Why am I doing that? What do you think? What's that? Yeah, for the inverse. What am I going to do first? What am I going to do to these 3 points? There you go. That's it. So this is, I'm going to erase that dash. That is our 1 to 1 graph of cosine. Now we're going to come up with a 1 to 1 graph of inverse cosine. Okay, so Andrew, what did I do? What do you think we should do first to make it easy to kind of map out what the graph is going to be? I tried that first time, but we struggled a little bit. What next? I'll do that last. What could I do after that? You got the right idea. Yeah, we're going to just flip these points. We'll flip all the points. So now we're going to do, scooch a little bit further down. So we're going to do inverse, I'm sorry. Let's just make sure that we're clear. This is cosine, all right, 1 to 1. Now I'm going to graph inverse cosine. Okay, so I'm going to flip all those points. So let's see. Brandon, flip those points for us. Tell us what they should be. 1, 0. 0. Yeah. Negative 1. Okay. And then we'll see what happens. So 1, 0. 0 pi over 2, negative 1 pi. So I've got to flip, what I can tell you is the curvature goes like this. It goes, if I flip that way. And how can you verify this picture real quick? Calculator. Just go in, graph cosine x, make sure you're in radians, and now we'll do domain and range. So what do you see as the domain of this graph? Yeah, what's the range? All right. So there's no negative y's on this. That means there's no negative angles. So that means if you go to type stuff in on your calculator, your answer always has to be a positive angle. It has to be an angle from 0 to pi. Okay? So your angles that you get, so the y are your angles. The input are your ratios. Now, I like to put my calculator in degrees so that my angles make sense. So real quick, put your calculator in degree mode. Let's test this button out and let's see if it makes sense. All right. Let's try inverse cosine of 0 and see what you get. What do you get? 90, which is the point pi over 2, but I like radian, because it won't give you power of 2, it'll give you like 1.5, 7. All right, there's that. So you get 90, which we can then convert to power of 2, all right? What is a ratio from so Austin, what's a ratio from a triangle that we know for cosine? So now I'm going to test you on your special triangles. Think about the triangles. Can you give us a ratio from a triangle that you know for cosine? Excellent. Let's do this. How about we make it negative just to see if it gives us a positive answer? So let's do negative square root of 3 over 2, and let's see what answer it gives us. It's got to take a second and type it in. Should give you 150 degrees. Good. Why does it give us 150? Because look, negative square root of 3 over 2 is here. See, this would be x. You go up, and it gives you the point there. Notice your answer is, you got to look at these as y's, but so here's where this is crazy. You have to take two perspectives to these problems. This is where students have trouble. So here's what you have to do when you work this. In a second, we're going to have to work all this by hand. You're going to say, well, how am I going to know that that's the answer and that's the only answer you get? Here's what you got to see. You got to see that when the x is negative, my answer has to be between this. So when I see pi over 2 to pi, pi over 2 to pi, I picture this. Pi over 2 to pi like this. It's an angle here. That's what I picture. This pi over 2 to pi, I picture an angle there. So now I can draw the angle. Draw the perpendicular. I'm trying to find that angle. Well, if I know the ratio, if it's cosine from here, negative square root of 3 should be the what side? Adjacent. 2 should be the what? What should be the opposite? What should be the reference angle? 30. Thus, it'll be 150. So notice how I can't pinpoint that point by looking. I don't know what it is. I don't know. But I could draw the triangle here. So this range here tells me those angles. It's a little tough. It's a little crazy. Just like here. If you had said square root of 3 over 2, right? What do we know? Square root of 3 over 2 is here. So my answer, whatever my y is between 0 and pi over 2. So now I gotta go from, now I gotta think about angle. What quadrant is 0 to pi over 2 for angles? First. So I'm going to go over here. Now I know it's a first quadrant angle. Because 0 to pi over 2, make a triangle. It says the cosine of the angle should be square root of 3 over 2. So there's my angle, square root of 3 and 2. How do I know? Because it's cosine that's adjacent and hypotenuse. Reference angle is still what? 30. So that's the answer, right? So because you're in the first quadrant. That's kind of where we're headed a little bit. Okay? All I want to do today was get the 3 main graphs. Because it's exhausting. Like trust me, it tires me out as much as it tires you out. They're not pleasant. Okay. All right, you got that one. So I know I added some stuff to this, but let's take that off. So this is inverse cosine. What do inverse sine and inverse cosine have that's the same? Look at the two pictures. What do they have that's the same? One squiggles like this, the other one squiggles like that. Kind of. I mean, you could say that, but I think there's something else, like in terms of what's identical for them. Don't they? They both go negative 1 to 1. Why is that? As you go to the wave, they have the same what? Range, negative 1 to 1. Think that was the domain here came from the range from your wave. Okay. Now, why are the ranges different? This one, notice this one goes 0 to pi. Sine went negative pi over 2 to pi over 2 because it depended on the pieces we picked. You said negative pi over 2 to pi over 2. Well, that then became the range. And then somebody over here, I don't know, Spencer said, well, let's go 0 to pi. Remember, he said 0 0 to pi here, that 0 to pi now becomes the range there. It switches. All right, one more graph. What's left? Sine, cosine, tangent. So we're going to come up with inverse tangent. This one I think is a little bit easier. I think this is the easiest one, honestly. All right, so what is the graph of tangent? Or, yeah, just tangent. What does it look like? Very good. What's the first main cycle? Sorry, go ahead. Anybody? What does tangent look like? Not pi over 4 to pi over 4. It's got an asymptote. Where's the first asymptote at? Negative pi over 2 to pi over 2. And then it has like an increasing squiggle in between. I can stop there. Why is that? Why would I stop here? Well, if it repeats, then all the copies and pastes, then it will not be what? 1 to 1. So if I stop now, it's 1 to 1. So what's the domain for this? Negative pi over 2 to pi over 2. What's the range? Negative infinity to infinity, okay? Now, you know I like to split 3 points, so let's see. This one has 0, 0. If you remember when we did this the first time, there were 2 other points that we labeled. Do you remember what this point is and what this point is? So I'll give you a hint. It's pi over 4 something. What's tangent of 45? What's tangent of pi over 4? 1. 45, 45, 90, 1. So there's pi over 4, 1. This one was negative pi over 4. Well, if that's pi over 4, 1, this is negative pi over 4, negative 1. So there's your 3 main points. All right. Now we're going to come up with inverse tangent. All right. So let me ask you this. What's going to happen to these asymptotes? If we have vertical asymptotes on tangent, what happens when we go to the inverse? They're going to be horizontal. That's exactly right. So now you have a horizontal asymptote at pi over 2. And you have a horizontal asymptote at negative pi over 2. And then in between, there's my 0, 0. So I know now my domain is negative infinity to infinity. My range is negative pi over 2 to pi over 2. And now I have 3 points. Negative 1, negative pi over 4. 0, 0, 1, pi over 4. And you plot those. Negative 1, negative pi over 4, 1, pi over 4. Now, it doesn't just do this. Bless you. It doesn't just do this. What does it have to do? It's got to go forever, right? So it's got to go and get closer to this, and then it's got to go this way and get closer here. There you go. Here's your inverse tangent. Okay. Ready? Question. What am I asking for? What's that? When x is 0, what's? The y, and with it is also the angle, so that's exactly right. You're looking for the y, which is also the angle. Well, it's just called battleship. B7. This one is 0, you go. You can already see. When x is 0, what's the y? Done. That's your answer. Yeah? Not negative. Yeah, 5 or 4, see? That's the point. Now, again, how would I have worked this if I wanted to use a triangle? It's asking me, we're asking tangent of what angle gives us 1, all right? And I can see that my answer, notice, I can see that the answer has to be between 0 and pi over 2. How do I know this? How do I know that? I erased that guy. Here's 1, there's my point. How do I know that my answer has to go between 0 and pi over 2? What tells me on the board? Yeah, just, it's, because here's the graph, it's between 0 and pi over 2, I'm just looking there. Okay, so I know that the answer has to be between 0 and pi over 2 because that's what the graph is. Then now I can make it a triangle if I want it. I already know the answer is pi over 4, but I'm just saying, what if I can't see that point? What if I didn't know that point? How would I do it? Well, so now again, I like how you always say, we're looking for an angle which is also a y. Well, tangent 0 to pi over 2 is 0 to pi over 2 here. Notice how I take that range and I go back to the triangle system. And I know it's the same as a first quadrant angle. First quadrant angle, boom. What's the 1 stand for? Yeah, x, very good. X here, but on a triangle, now think, if this is a ratio, so this is what I'm saying, you gotta take 2's perspective. You're exactly right, it's an x here, but if it's an array, if it's a ratio, what ratio is that for tangent? 1 over 1, what are those called from SOHCAHTOA? Yeah, see that 1 is the x here, but it's also a ratio which means 1 over 1, it's opposite and adjacent. Now that helps me identify my triangle, which then I know the hypotenuse is what? Square 2, then I know my angle is actually what degrees? And that's why you get 45 degrees or pi over 4. And that's the only answer. I'll build off of this on Friday. Usually what I do is I present and I work a couple of problems, and in the next lesson, then we go deeper. Are you okay with that? That now, how many in here are not done with their quiz? Everybody else is done with their quiz? Yeah, you can, how many in here would like to work on their quiz today? All right, now let's say some of you are like, hey, you know what, man, I got the quiz done, I'm done. Guess what, this homework is open for you. You're ready to go. So if you want to go in there and start working, you can. Now, here's the type of problems we're going to get. So when we come in on Friday, the first thing I'm going to do, what do you think is the first thing I'm going to do? What do you think is the first thing I'm going to put on the board? Ashton, we come in on Friday. I'm going to continue with this lesson. Well, probably what's the first thing I'm going to put on the board? No idea. Anybody want to help him? What do you think is the first thing I'm going to put on the board Friday? I'm not done with this lesson. Those 3 graphs. Inverse sine, inverse cosine, inverse tangent. So here's where we're headed, just to give you an idea. All right, I'll give you one sample problem. Find the only way you can do cosine is if this is an angle. It is an angle. Because this means the angle whose sine is negative 5/12. So how do we do that, right? So let's think. So now, the way we're going to work this is, what would be helpful? If I want to do cosine, what picture would I like to have? You said sine?
Cosine.
If I want to do cosine of an angle, just think back to right triangle trick. What would you like to see? What would you like to have? If I said cosine of an angle, what would you like? What would make it easy?
Triangle?
A triangle. That's exactly right. That's where we're at. So what you're going to do is you're going to have to make triangles. So the question is, where is this angle? and my lesson today has taught you where it is. So that's my question for you. If you know where this angle is, now we can draw the angle. Once we can draw the angle, then we already know the sides. Because if it's sine, if that's the ratio from sine, what's the 5? What's the negative 5? What's the 12? I messed this up, sorry. It's 13. If it's 12, I need is the other side. So, question. Where is this angle? This is what I've hopefully taught you today. It's not easy. So, first thing you do is forget about that. Now you gotta figure out where's that angle. So I need to know, the best way to answer it is you could say 0 to pi over 2. Pi over 2 to pi, or 0 to negative pi over 2. Because if you think about all our graphs, either go 0 to pi over 2, 0 to negative pi over 2, or pi over 2 to pi. So the question is, forget about the cosine for now, where is that angle? No, cannot be. Nothing is in quadrant 3 from this lesson. Okay, why? Listen to what he's saying, sorry to interrupt you. You are going to have to, this is where I'm saying the dual perspective. You're going to have to do exactly what Austin is getting ready to tell you. So the first thing, when I see that, what graph should I look at, Austin? I have 3 graphs I've given you today. What graph should I look at? Inverse sine. That's the first one. I'm going to go to inverse sine. All right, here's the graph. Right? It looks like this. Right? Everybody with me on that? There's inverse sine. Okay, now explain to us why it's fourth quadrant.
Because hypotenuse can't be a negative in a triangle.
Okay.
And so the 5 has to be a negative.
Okay. Four. Right?
The 4 has to be the adjacent has to be 5.
All right, let me give you an easy way, because it's like a merry-go-round. Let me give you an easy way how you're going to know. All right, everybody pay attention to this. Okay, look up here. This is because this is the, in terms of the hardest thing I teach, this is the hardest thing I teach because you have to have dual perspective. You got 2 things that you're looking at. One thing is this right here is asking for the output over here, because that's what this is. If this is the graph, inverse sine, negative 5/13. One answer is it's the y. Remember, what was the other? You kept saying it, which I like. This also, we're looking for what? We're looking for the y, but we're also looking for the what? Angle. Very good. Okay. This in here is your what? Very good. It's the x, and it's also the ratio. All right. Here's my dual perspective. In terms of the graph, this is the x, negative 5/13. So my point is here. So my answer has to be between 0 and negative pi over 2. So I know whatever my answer is, it's got to be between 0 and negative pi over 2. Then at that point, this is what we're going to go through on Friday. You got to now change your perspective. You got to now change from this graph to triangles. That's your ratio, and that's your angle. Has to be there. So now I would ask you, what quadrant is 0 to negative pi over 2? Fourth. That's why I did this. See? 0 to negative pi over 2 is fourth quadrant. So this answer here, the only way we're going to get it is by drawing our triangle here. All right, I make my triangle. What do I know? That there, the negative 5 and the 13 should be what parts of this triangle? The opposite, hypotenuse. I gave it away. What's the adjacent? 12. This is my angle. Whatever you want to call it. You can call it theta. Now, if I want to find cosine of this angle, now I go back to SOHCAHTOA. This is where it's going to be hard. You're going to have to go graph and know from the graph, interpret that this is a fourth quadrant angle because of my output, draw my triangle, and then now you got to do is cosine. So what's the cosine from here? 12, 13. And that's the answer. And that's what I have to teach you on Friday. All right. I know. So you gotta let it marinate. Don't get, look, this is, what are you in? You're in a college level trigonometry class. Right now, this is trig. Nobody said this is easy. All I need you to go home today is with what? What do you need to go home with today? Colton, help your buddy out here. He didn't answer it last time. The 3 graphs. I need you to look at those 3 graphs. It would be great if you could get a fake tattoo of all 3. I would love that. Fake tattoo. Don't go do a real tattoo. Get a fake tattoo of all 3. But I'm saying mentally, try to know them pretty well, right? That you could draw them. Then, last question again, real quick. I'm gonna point, you're gonna tell me what the answer is, or what does this stand for? A ratio, or what else? X, an input. All right, the answer then to this has to be a Y, so an output or an, there you go. That's what we're doing. Okay, and I'll help you with that on Friday. All right, and we stop. Now I only get to teach this 2 more times, great.